Thanks, Martin, and thank you, Marco. But now, finally, we come to the last session of Sharing Inspiration, the energy, the elephant in the room. Harald Herzig works for the company Mainova in Germany, and he's going to present us a talk about the challenges which face the energy industry, particularly interesting, coming just after COP26 in Scotland. So Harald, over to you.
Thank you very much. Hello all. I'm already feeling a little bit like the elephant in the room because I'm from the energy industry. So you see my screen and you can hear me?
Perfectly, Harald. Yes, perfect.
Okay. Then I will start, and I think it's a little bit a different thing now because I'm working for a regional energy supplier in Germany. I'm working a long time in energy business, worked for Centrica, British Gas, so the biggest UK supplier, worked for Gazprom Marketing and Trading, which is the trading arm of the famous Gazprom on that side. And now here I'm responsible for the supply of the area, which means I have a portfolio of around 15 terawatt hour in comparison to the others with microwatt, terawatt hours of gas, 10 terawatt hours of power. We have a production capacity of 600 megawatt on fossil fuels, so gas and coal, and around 200 megawatts on solar, wind, and a little bit of water is in. So that's the side where I'm coming from. On the short introduction, I'm focusing on prices and prices of natural gas, power and emissions, so CO2, which is quite important for the environment. I can't do a deep dive, so it's just some points which I pick out. So please, if you have any question, something to ask the question if something is not clear. And I use simplifications. So gas is just used for heating. We have a very high demand in winter and low demand in summer, which more or less is in the market. So if I use the word power, we in the energy business here use power as the electricity market. If we trade power, we trade electricity. Power, from our point of view, is used for light and cooking for production, and has a very spiky demand during the days and in the days, because power storage is not economical. That's an assumption at the moment here, and you have to do it real time. So if you use power, you have to produce it at the same point in time, which leads to very spiky prices also. And if we have just some days now in the past, we have some hours and we have prices down to a quarter of an hour, which are around just 100, 120 euros, 200 euros, and suddenly on 1 hour you have a price which is around 300 euros. If we speak about a longer period, which is from January here now to now the last days in November, we have prices started with 40 to 80 euros, so step by step. We had also then in summer times prices on some days which are below zero, which means you're producing energy and you have to pay for it. And the customer is getting it for free, and he is getting reimbursed for taking the power on some hours and days. And then over the last 2 months on the right hand, you see that we had a huge price spikes, which is going up to, for one single day, we had around 320 euros. We had some days with 200 euros, which means that coming from the level of 40 euros, the prices are nearly 8 times the price we had a year ago, and nearly 10 times the price we had 2 years ago. I speak also a little bit now about the natural gas. Natural gas, for me, is 2 groups. On the one side, you have the LNG, liquefied natural gas, which is minus 160 a little bit degrees. It's liquid and we can transport it on ships. And you have the pipeline gas, which is pumped through pipes from point A to point B, which also means then that pipeline gas, it's clear where it's coming from and where it's going to, A ship with LNG is coming from a harbor and can go all over the world. So it's not clear whether it's coming to Europe, Asia, or anywhere else. That means also on the gas side, you have regional markets with pipeline gas, and you have the worldwide market on the LNG side. On the natural gas side, in comparison to power, we have really storages, and you need the storage to cover the high demand in winter. Because winter demand is around 80% of the overall yearly demand, and summer just 20%. And then the disclaimer below, this is not the official Mainova meaning, it's my personal presentation you see now, so please, for private use. I will now jump in after the introduction into the European natural gas sources, natural gas market. We have pipeline gas and we have LNG. So the LNG is the yellow dashed arrows, is produced also in Norway, Russia, worldwide, transported with the ships, and is coming from all over the world, mainly from Qatar and usually US, into the European markets, you see here. The European gas market has a demand of around 380 BCM, which is billion cubic meters. And 1 cubic meter is approximately 11 kilowatt hours, which means 380 BCM are around 4,200 terawatt hours in energy units, the market. We are quite well supplied via pipelines, where you have, starting from the south, North Africa delivering into Spain and Italy with pipelines, of Maghreb, for example, around, I think, 50, 60 BCM. You have on the right side here the Southern Gas Corridor, which is relatively new, just about 10 years old, coming from Azerbaijan through Turkey, then going through Greece, also into Italy. In Italy, around 10 BCM, 10 billion cubic meters are coming in. Then you have the Russian pipeline starting, where you have Turk Stream and Blue Stream through the Black Sea, going into Turkey and then delivering the countries over there. You have the Brotherhood pipeline, which is a famous pipeline going through the Ukraine. You have the Yamal pipeline, quite new also, around 15 years old. So Brotherhood, it's from the late 60s, so we speak about 60 years old. Yamal pipeline is about 15 years old now, going through Belarus, Poland, ending here in Germany. And then you have the famous ones, which are the Nord Stream 1 and 2. Nord Stream 1, 3 or 4 years now in place, and Nord Stream 2, which is constructed, which is ready to deliver, but the last permissions are missing. And we had the news yesterday in the market that it will take still a little bit more time. So Nord Stream 2 can deliver, but it's not allowed to deliver. Russian markets. If you have followed, and I don't know whether you did or not, the recent press releases in the normal press already, also, it was always a question, why isn't Russia delivering more gas through the Ukraine? It is a political thing, clearly, yes. But also you have to see that if you look at these pipelines, the Brotherhood, the eldest ones, and Nord Stream, the newest ones, they're delivered by completely different fields, different production areas. Brotherhood is around here in Russia, which means the gas has to be produced here and brought through the Ukraine. And Nord Stream is delivered by the Yamal Peninsula, where the big gas fields now are. And between these two areas, the northern one and the southern one in Russia, the production areas, there is nearly no connection. So just to be clear, gas which has to be delivered through Nord Stream can't be delivered through the Ukraine line because there is no pipeline within between. And that makes it maybe for Gazprom a little bit more complex to bring a lot of more gas at the moment to the markets. Just for you now, a little bit an overview on the pipeline capacities and production. If we speak about Russian pipelines, then overall we have a volume or capacity of 315 BCM, which can be just delivered from Russia to Europe. And if you look at the European demand, which is 380 BCM, a lot of gas can come from Russia if we need it. If we look at the natural gas production in 2020, Norway, which is the biggest European producer, I would say, if we don't count Gazprom, a little bit more than 110 BCM. The Netherlands, a very important producer, now just producing around 20 BCM. And Russia, so Gazprom most, is producing around 600 BCM of natural gas. Germany, in comparison, 6 BCM, so quite small. If we look at that picture, we would see that we are quite well supplied. We have a lot of production, we have a lot of pipelines, but what we see, and that is one thing, here on the right side, when we look at the natural gas prices, over the last few months, we had a price spike which was incredible. We never have seen that in history. And I took here the gas price developments for a frontier delivery, which means if I'm here now in 21 buying gas, the delivery of that gas will be in 2022. So it's always the frontier which is traded. Here in comparison on the left side, with the red circle, you see what happened in 2008-9 when we had the quite economic push. Everything was bullish going on, and then suddenly Lehman crashed down. We had the big banking crisis. We had the world economic crisis, where the prices went from 25 euros up to more than 40, which was a huge movement. And after the crisis, it went down to 12 euros on that side. And if you look at the right side, we had in 2020, we had the Corona crisis, which led us also to prices around 10, 12 euros on that side. Corona is still there, but markets are recovering. And suddenly we are coming from 12 euros. And on the high, we had nearly 70, so 68 euros for the year ahead delivery. It's now a little bit relaxing, but we are now here facing prices we have never seen in the market. And if you have to buy more gas for your customers, or if you're a customer, the prices will be very high for that winter and also for next year. The reasons are we had a very cold winter in 2021, so 2020 to 21. Especially February and March were cold, so gas storage levels were very, very low. Then we have low Western European production, as we saw Germany just 6 BCM, the Netherlands going down to 20 BCM. 15 years ago, Netherlands have been producing 60 BCM, quite high, and the Norwegians are at the limit with 100, and that's already in the market. So low volumes which are coming here. And then less LNG is coming to Europe. If we speak about some kind of security of supply, it means LNG is not delivering security of supply because LNG can go everywhere. And in Asia, the prices are at the moment even higher than we have them here in Europe. So gas on the ship is delivered to Asia, not to Europe at the moment. And that's why this year we have, for the first year in about 60 years of gas industry, a year where physical supply constraints are possible, which would mean that big industrials might not get the gas in some days they need for production. It means not that household companies or end users will be cut off. That is just for the big industrials a question on that. And the consequence is that on the power production side, gas is very expensive, coal not so expensive. So more power will be produced by coal, and especially lignite. So the pollution, CO2, will rise in this winter significantly because the production has changed. If we look at emissions prices, so it's EUA prices, European Emissions Allowances, which is the #1 climate price. So this is the price for emitting 1 ton of CO2. And in the market, the big industrials have to pay, energy companies have to pay. So the big polluters have to pay, not the household companies at the moment. Might change on that. So that is the signal. What is the price we give to the CO2 pollution? And if we look at the last years, so here in the red circle, 2013, 15, 17, it was very, very cheap. So in the low, we had €3, which for 1 ton of CO2 pollution, nothing. And also here, we see now that in 2021, we have a quite big change. So where we now around at prices around €60, €66. But if we speak about a really influence and change, we need far higher prices. If you read in the press, it's at least €120. But in my opinion, this price has to rise to far more than €120, around €200, that it will have really the influence that coal production will stop, that all the economical influence and economical incentives are set in the right way. Now we have seen gas prices are high, emissions prices are high. Naturally, it's also for the power price. If we see the German power price at the moment, we are at levels we have never seen in history. On the right side, current price levels. On the left side, in the red circle, you see also what happened on the Lehman crisis, I would say. Prices around 80, 90 euros in 2008-9, and now we had price spikes up to 170 euros on the last 2-3 days, which is for the market especially complex. And that is one thing. These costs we see here, for me, it's the overall energy market, and I have to deliver to customers. This will has to be reflected also in prices for end customers. And this is a development all over Europe. So if you look at the French prices, it's the same. Spain, the prices, it's the same. In the UK, it's even worse because the prices are far higher on that side. So now we have seen a little bit what the prices did over the last months. The prices are very, very high. But that is just one challenge we are facing at the moment. It's the energy industry, from my point of view, and which will also be difficult for the customers because the bill will rise significantly. But on the energy side, we have a few more problems. 3 points which I have here. The one is the market design. The other is power production. And the third is power and gas grids, which have to be developed. When I speak about market design, then it is usually the way that the different ways of producing power have different marginal costs on that side. So if we go on the right-hand side of that diagram, power production by oil is expensive. It's very, very expensive. Here it's gas-fired power plants, which is also with a high price. Coal, which is hard coal, then the lignite ones, and the marginal price, and that's just the marginal price of nuclear power, is relatively low. But the marginal price of renewables, if we speak about solar and wind and water, is nearly zero. And the more renewable capacity, renewable power we get into the market, the more the green line will shift to the right, which means if I have a certain demand, it will meet the supply, and we get an electricity price at a certain level. If we have a lot of solar and wind power in the market, the green curve will switch to the right. And then we have a situation where we have an average electricity demand, but to be honest, no real price, because we can't calculate that we need 1 ton of coal, which costs 100 euros to produce it. It's there. Sun is shining, wind is blowing, it's there. And that is a thing where the markets at the moment where we pay kilowatt hour, so the kilowatt hour which is produced in the hour, has to change in a price where we have more capacity pricing. So we have to pay for the kilowatt. I think customers in Spain, that's what I know that already, that the price they pay for the installations to the house is different if they get a bigger grid connection or a smaller grid, and is cheaper, sorry, if they have a smaller grid connection. In Germany, it's still one price for all. So this is one thing where the market will be completely disturbed because the price signals will not work anymore. It's for an energy company a real problem. Then you have a problem, or it's a challenge, I would then say, on the power production. The renewable power production is relying on wind and sun. So just if the sun is shining, you can get solar power. And you can't bring the sun to the point to shine more. So the grid can't be steered in that way anymore. And if you remember at the beginning, I said power has to be produced at the same point in time then it is used. So the steering and the frequency in the grid has to be kept in a quite small range. And that's for the companies a very complex thing now if more renewable power is in on that side. So that makes the market also for us more challenging as energy company. And the third thing is, if you got for fossil fuels on the power side, so coal plant, gas plant, even nuclear plant, you can build it wherever you need it because you can bring the coal in and so on. For renewables power production, usually you build it there where the wind is blowing and where the sun is shining most and where you have some space, because solar panels use a lot of space on that side. So you can't bring the power production near to your customers anymore. So you need more grids. You have to invest in grids. When we speak about dozens of billions just for Germany, which has to be invested there. And also on the smaller grids, on the retail market. Suddenly the customers, the households have solar panels on their house. Suddenly they have electric cars. They need a completely different grid connection. And that also has to be built. So there are different estimations how many billion euros that will cost. But it's 3-digit billion euros, and it's might be a high 3-digit number on that side. So huge costs which are coming to the company and to the companies. And this will be a cost the customer at the end also has to pay. So we have to see that. A little bit of view on PV capacity, so solar panels on that side. If we speak about the need of solar panels and the solar power production, we are here at the area of 2020 now. The capacity has to triple until 2030. And it has to be 10 times higher till 2045 to get the solar power we need for the markets. Because we switch off coal, we switch off gas as much as we can, completely it will not work. And we switch off in Germany at least, the nuclear power plants. In other countries in Europe, they build new ones. Therefore, we need wind and solar power. And that we need in a huge capacity, which also will lead that we need the space for the solar panels. And we saw that in Germany, if we would say to get climate neutral in Germany, just by solar power, we need 8,400 square kilometers of space to build all the solar power panels on, which is around the space which Corsica is using on that side. And to be honest, where should we take the space from? It's the land is, especially in Germany, relatively expensive, and therefore this will be a challenge for the market also on that side. And I remember the discussions I had with Christine on that. So everything we can't do with solar panels, even if we want. We need wind, but wind also needs the space on that. How can we get them to a solution for the market? Because at the end, we have an environmental problem. We can't produce energy with coal anymore, with gas anymore. But also we know that just with solar panels, it will not work. And I'm economist, I'm trader. And for me, it is one thing, we have to send the market a cost signal, which is a clear cost allocation in the light of the climate change. The cost for emissions have to bear all effects which are in. So then the price for electricity produced, which we have at the moment, take a number, it's around 50, will be in 10, 15 years, not 50, but it will be 250. So the energy cost will rise significantly, which also then mean the transportation costs. So if you fly from point 1 to B, if you use also the train, electric trains, if you use your own car, even if it's electric car, the cost of that will rise significantly, and also for goods on that side. And on the other hand, if we speak about cost allocation, we have to speak also about subsidies. So subsidies in the markets we see at the moment have to be reduced significantly, especially if you look, for example, on aircraft. Kerosene is far too cheap on that side. So that is one thing. Next thing, clear cost allocation is needed to incentivize the companies and the people, the human beings. So it has to be worse for the companies to save power, to use less on that side. And that's just if we get all costs which are included in the production, if we get that to the power price. And then the clear cost allocation is needed, that the cost has also to show the consequence of producing the power, of doing that transportation way. Which is, for example, in Germany, the cost of storage of nuclear waste for the next 300 years. We would need it for 3,000 years, but that's not possible. The costs also we have to see, if we look at electric vehicles, for the battery production. What is in there in that battery? How does that work, and how costly that really is? And then we have to calculate also the cost, for example, floodings, for all that what we see as a result of that climate change. That has to be into the commodities on the energy side, and also on the power price, on the electricity price. It will just work if we have really the real right price on that. Everything which we see at the moment, where some things are prohibited now, people find a way around that. That's always the case we have seen. And now I will come to one thing where it's, will the 1.5 degree target work? And that's now my view a little bit from the energy market. Often you hear that, for example, renewable energy is already around 50% of the market. Yes, but it's 50% of the power market. So renewable energy in Germany, for example, last year was nearly 50% of the overall power production market. But the important question is what it is in comparison to the total primary energy consumption. So the overall energy consumption with the traffic, so with the petroleum in, with the kerosene in on that side. And there, if we look at the share of renewable energy on total primary energy consumption in Europe, it was 6.6%. In 2019, it was 15.5%. If I look at these two numbers and calculate to 2040, will we be then at 35%? 35% is by far not enough to get these problems solved, which we have on that side. So I think, and that's why it's in red, something has to happen. We have to need the clear cost allocation. If you look at the prices I showed beforehand, I think even we are on the right way on that, because the prices are now far, far higher. And that will mean that renewable energy in comparison will be then cheaper. Here is the picture of some of the countries we had. On the left side, EU 28. Then you have Austria, Denmark, France. And from all these countries, as you see here, Iceland in the middle is a quite nice country with 90% of renewable production. But even Iceland, with all the thermal power, has not 100%. They can reach 100%, maybe. And Norway, which is around 50%, but Norway I find quite interesting because from 2000 to 2019, the share in Norwegian renewable energy production went down on that side. It's still by far higher than everywhere else. Sweden is quite good also, but it was not rising on that side. So if you look at that point, there is still a lot to do if we want to say we need renewable power, renewable energy, in comparison to the total primary energy consumption. And that is one thing where I gave you an overview of all the story, the prices which are going the right direction, the prices which have to be higher, and the efforts we still have to do, we need on the renewable energy production to get that far more into the markets. I didn't speak about hydrogen, because hydrogen is another topic, but we need also a lot of more hydrogen into the market to use less natural gas on that side. Okay, that was my overview over the energy market.
Harald, thank you very, very much indeed for that. That was absolutely fascinating. I'm overwhelmed by some of the data which you presented there. And I thank you very much for that. I don't know if there's any questions that have appeared in the chat room. I can't see any, but I do have a question for you. You presented a piece right at the beginning of your talk about how you sometimes have to produce energy and pay for it.
Yeah. Give me a second.
It was, I'm not quite sure that I understood that.
It is, for example, and that is especially a thing, if you think about the next slide, the slide where I showed that the marginal price of production of renewable energy is nearly zero. And if you have, for example, in wind, in Germany, the situation that you have a lot of solar power in and a lot of wind, then you don't know where to bring the power in. And at the other hand, nuclear power plants and lignite plants on these days still have to produce, because if you want to switch up a nuclear power plant, it will take weeks to go down. If you want to switch up a lignite plant, it takes time. And therefore, you have some days where even you produce power and you have to pay the market that they take it. Nice.
Right, yeah. So gas is better because you can switch gas off quickly.
You can switch it off and you can store it.
Yeah.
Gas, you have your storage and you put it into the storage. It's quite easy on that. So negative gas prices are not impossible, but I haven't seen them. I have seen a negative oil price.
Okay.
It was a Corona crisis for 1 day or 2 days. We had a negative oil price, which was also unbelievable.
Hmm.
Yeah.
And you also drew, for me, I think the most important conclusion was that we really are going to have to pay a very great deal more for energy than we do at the moment. And is it your opinion, your impression that this will ultimately force lifestyles to change right across Western Europe, for example?
Frankly, yes.
Yeah.
Yes, because if we are in that point of time that we have planes on renewables, that we have transportation completely on renewables, so that what I had at the end, that we still for the total primary energy consumption, if we're there completely renewable, then you can do it again because then you don't pollute the environment. But as long as we are not there, and that will take 50, 60 years, to be honest, it will be a real issue. And as long as we're not there, as long as our car is not climate neutral, or the plane is not climate neutral, we have to pay a lot more to get the real price in. And for me, as I said, I'm trader. You have to have the price signal. If the price signal is not coming, then the people don't think about it.
Yeah. So it's the elephant in the room. But primary energy really is the elephant in the room, which we just don't see it.
Yeah. To be honest, yes. And that was for me also interesting when I looked up the numbers and I did the preparation for the presentation. I'm a little bit more pessimistic now, but
that's not good.
that's not good. But I know that the price developments we see at the moment are the right direction. But then the politicians have to react on the right way, because in Germany, for example, the politicians are now in that question: how can we reduce the power price? How can we reduce the costs for the people going into the company? So we have some subsidies on the transportation if you go from home to company. They want to raise that, but that's completely contra the price signals we see at the moment. And if the politicians start to work against it, where shall it end? So that is also quite, frightening scenario. The prices are going up, but then we get subsidies.
Mhm.
Yes.
Um,
I was going to
There's a
say,
question from Fred. Sorry, there's a question from Fred in
good.
the Q&A.
I
So
can't see it, please. Yeah.
yeah, hang on a second. I can't bring up the Q&A at the moment. I don't know where.
I see it.
Yeah.
Frederick Foch,
Got
he
it.
mentioned hydrogen replacing natural gas. What is the source of hydrogen? Is it cost effective to make it?
Do we have another hour? No. I make it short, the answer. At the moment, cost effective, no. But if we look at the gas prices, which we had over the last days, yes. Even the natural gas price, the hydrogen price, as far as I remember, was around 68 euros. So it's getting into that. But the problem is we don't have the big installations. And then how is hydrogen produced? So hydrogen is nice because you have it in different colors. Sorry, it doesn't exist in different colors, but for the energy business, you have the blue one, you have the green one, you have the gray one, you have the turquoise one, you have the red one, and you have the black one. The green one is the nice one, no emissions. The blue one is made out of natural gas, so you have still CO2. I think it's a turquoise one, sorry, means then the blue one with carbon storage, which is also quite nice for the environment. Then you have different other ways to make it, but nothing is really cost effective, and we don't have the possibility in size at the moment to do that. but it is clearly the future. And it will come over the next 5, 6 to 10 years, and it will step by step replace natural gas. Yes.
And do you think that it will be Iceland which will produce the hydrogen from its vast reserves of geothermal energy? You've just shown a remarkable graph at
A
the end.
little bit, maybe a little bit. I think that it will be Saudi Arabia, it will be North Africa, because they can build a lot of solar panels. They have a lot of space there in the deserts and can produce the power to produce then the hydrogen. And hydrogen can be delivered by ship on that side. It will be a little bit all over the world, but in longer term, might be also a lot in Europe, because there are some, how do you call it, some tries to get the hydrogen out of the air. And if that works, then we can build it everywhere. But at the moment, most probable, where you have a lot of space, put solar panels or solar power in and get then the hydrogen done.
And Katie Bars asks about possibly using more solar heat and to use home batteries to overcome some problems. I also saw a comment from Hans Martin just at the same time, but
yes, that will help. It's a thing where if they speak about solar, then for me it's clear countries like Spain, southern Italy, it's quite easy. And then also with solar heating on that side. If we speak about countries like Germany, it still works. If we go to Norway, I think solar heating will be less efficient on that side, because especially in winter it's very cold. But clearly, yes, it's one step to that. And then to bring the storages into the households, also one step. But that is also the issue then for the local distributors of energy, because then you have to get other and bilateral grid connections, which are still not in place. And that is a huge investment in grids, especially retail grids, which is then needed at the end.
and I suppose it then becomes even more complicated to match demand to supply. Is that right? The more
If the company of the grid company is then allowed to use your storage for balancing, then it will be easier. If not, it will be still more unpredictable on that side.
Okay.
But that can be solved over time. Can be solved over time.
Okay, so there's a little bit of optimism there, perhaps.
May I ask something about the heating? Because if you have solar thermy, where the sun is heating up water pipes in the panel, and then you have the storage, you have a big water storage, and then you don't need a grid. This is an individual solution for every house, which is possible.
Yes, but then you need for heat, just for heating, not for electricity.
No, for heating and for your water usage when you need warm water.
Yeah, it works already, and it's one thing I already have placed the tank into my cellar, for example. I still need the panels upside with the next thing, the next project. But that is really one thing where you can save on the heating side and on the warm water side. Yes, because
and you have an efficacy which is really high.
Sorry?
The output is really high. I mean, you're losing only about 10%, so you have 90% of efficiency or efficacy.
Yeah, that is also one thing I would recommend everyone who makes a new house or is getting new heating in. Add this thing, because that's not so expensive on that side. So the panels with it's no water in, but it's the heating material. It's not cheap, but it's not so expensive. The tank in the cellar, if you have the space, it's quite fine. So it works relatively easy. Even better Southern Europe than Northern Europe.
Okay. Well, I thank you once again, Harald, and I thank also Franklin Nate, Hans Martin Hilbig, Markku Parkkonen and Katie Bars for their presentations. I think it's been a wonderful tour.